Hello, and welcome to Backer Breaks It Down. In this episode, we are going to solve equations and we're going to use logarithms to do that. Okay. So we have solved exponential equations before, and we did so by rewriting the equations so that the bases on each side were the same. Unfortunately, you can't do that with all equations. Here are two examples. Like 4 to the x equals 15. I can't rewrite 15 as base 4. I can't even rewrite it as base 2. 10 to the x power equals 120,000. Yeah, I can't get 120,000 to be 10 to any power. So remember, logarithms and exponentials, they're inverse functions, so they undo each other. So we can use logarithms to solve these equations. And this is how we do that. Okay, step one is to isolate the exponential expression. So get b to the x power all by itself, if necessary. In the example below, it's not necessary. My exponential expression is already isolated, but that's what you want it to look like. Step two, you want to take the natural log of both sides of the equation. Okay, and so notice that's what they did. They took the natural log of 4 to the x, they took the natural log of 15. So this will undo your exponent. So when it says simplify using one of the following properties, I'm in the problem below taking the natural log of b to the x power. So this becomes x times the natural log of b. Think of it this way. By taking the natural log of both sides, the exponent is free and it's going to come out in front. See? Okay. So they took the natural log of 4 to the exponent is free, and it came out in front. And that's how they're getting x natural log of 4. Okay. And then finally, solve for the variable. So you'll notice that they are dividing both sides by the natural log of 4, and then they're calculating the natural log of 15 divided by the natural log of 4 is approximately 1.953. Okay. There is an additional property that you may have noticed, this one right here, involving the natural log of base e, right? If you look over on the right side of my screen, right here, I'm showing you that the natural log of e to the x is simply x. And that is because, and if you don't believe me, if you calculate the natural log of e on your calculator right now, you'll notice that you get 1. Okay, so I can take like the natural log of e to the x power, and that frees the exponent. The exponent comes out in front. So then I'd have x times the natural log of e, but since the natural log of e is simply 1, all I'm left with is x, because x times 1 is x. So that's what that means. Okay, so let's actually see the whole process step by step. All right, so problem number 1, we have 15 times 2.3 to the x power is 63. So I'm referring to my flowchart on my summary sheet, because eventually we're going to be relying on that quite a bit. So here we have an exponential equation. Can the bases be written the same? I'm not thinking so. 2.3. So I'm going to use my natural logarithm. So step 1, I want to isolate the exponential expression. So in this problem here, that means I have to divide both sides by 15. Okay. So I do that, calculate, and I get 4.2. Okay. So that's step 1. Step 1 is to isolate. Step 2, take the natural log of both sides. So that's really easy to do. I'm going to take the natural log on the left. I'm going to take the natural log on the right. Step 3, simplify using, all right, so that, remember, we take the natural log, the exponent is free, so it's going to come out in front. So now I have x times the natural log of 2.3 is equal to the natural log of 4.2. And then step 4, solve for the variable. So in order to get the variable all by itself, I'm going to have to divide both sides by the natural log of 2.3. So this is like what I'm going to calculate. I'm going to calculate the natural log of 4.2 divided by the natural log of 2.3. and I get that x is approximately 1.723. Check out another one. So, can I get the bases to be the same? I'm thinking no. So step one is to isolate the exponential expression. This one is isolated. Step two, take the natural log of both sides. So I'm going to take the natural log on the left. I'm going to take the natural log on the right. And you know what that means? That means our exponent is free. It's going to come out in front. Now this exponent is a quantity, so I'm going to put my quantity in parentheses just to protect it. Okay, so I have x plus 2 times the natural log of 7 is equal to the natural log of 410. So that was me simplifying it, and now I'm ready to solve for the variable. So in order to get x all by itself, I'm first going to want to do division, just like the previous problem. I'm going to want to divide both sides by the natural log of 7, because doing so is going to get x plus 2 all by itself. Okay, because these would cancel each other out. So now I have x plus 2 is equal to the natural log of 410 divided by the natural log of 7. So I'd want to then subtract 2 from both sides. And then I'll be ready to calculate. So when I calculate, I end up with 1.092. All right, one more problem. This one has base e. I'm still using the natural log process. So step one is to isolate the exponential expression. So to get my base e all by itself, I'm going to have to divide both sides by 10. This is going to give me e to the 3x minus 7 power is equal to 2. So now I'm ready to take the natural log of both sides. Natural log on the left, natural log on the right. Now recall that when you take the natural log of e to some power, all you're left with is the power. And like this specific scenario here is being illustrated, that when I take the natural log of e to the 3x minus 7, all that remains is 3x minus 7. So I have 3x minus 7 is equal to the natural log of 2. And then I'm just going to go about getting x all by itself. So to get x all by itself, I'll have to add 7 to both sides. And then I'd have to divide both sides by 3. So this is what I want to calculate. Let me just highlight it for you. So I'm going to calculate the natural log of 2 plus 7, and I'm going to divide that by 3. So I get that x is approximately 2.564. Okay, but this is how we can solve exponential equations when the bases can't be written the same. We're going to use natural logarithms to solve. So step one, isolate the exponential expression. Step two, take the natural log of both sides. Step three, simplify. Remember, the exponent is free. It'll come out in front. And then step four, solve for the variable. And that's how Backer breaks it down.